Good day, everyone. My name is Isa Cherbab, and today we are going to discuss, or I am going to discuss about the systems of equations. There are three methods: the Cramer's method, Gauss-Jordan method, and the inverse method. So we have here the system, which is the number 35. Number 35 to 40. So let us have to answer 35. So, 6.3x plus 2.1y is equal to 18.9. 1.5x plus 3.4y is equal to negative 4.2. So, let us have to answer first the Cramer's method. So, 6.3x plus 2.1y is equal to 18.9. 1.5x plus 3.4y is equal to negative 4.2. So, we are going to separate the A and the B for the coefficient matrix and the constant matrix. A is equal to 6.3, 1.5, 2.1, 3.4. B is 18.9 and negative 4.2. So, we are going to cross multiply the A value in order to get the determinant A. So, 6.3 times 3.4 minus 2.1 times 1.5 is equal to 21.42 minus 3.15, and it results to determinant A is equal to 18.27. So, next, we are going to get the determinant X. So, we have to replace the constant matrix, the B, for the first column and copy the second column from the A to the right side. So, 18.9, negative 4.2, 2.1, 3.4. So, cross multiply again. So, it results to 64.26 minus negative 8.82. So, our determinant X is equal to 73.08. So, next, we are going to get its determinant Y. Since it is 2 by 2 matrix, or there are 2 by 2, 2 rows and 2 columns. So, X and Y is the one that we are going to get. So, determinant Y is equal to 6.3, 1.5, 18.9, negative 4.2. So, it results from the cross multiplication, 26.46 minus 28.35. So, our determinant Y is equal to negative 54.81. So, we are going to divide from the determinant X over the determinant and the determinant Y over the determinant. So, 73.08 divided by 18.27 is equal to 4, and negative 54.81 over 18.27 is equal to negative 3. So, next, let us proceed with the Gauss-Jordan method. We are going to copy the given equation. So, let us separate with the augmented matrix. 6.3, 1.5, 2.1, 3.4, and for the left side, we have 18.9 and negative 4.2. So, we have here the formula in order to get the one value of the row 1, column 1. So, row 1 divided by 6.3. So, it results to 1 and 0.33, and for the right side we have 3. So, copy the row 2. Okay, now we are going to have another formula in order to make 1.50 in row 2. So, we have the formula row 2 minus 1.5 row 1 is equal to R2. So, it results to 0, 2.9, and negative 8.7. So, for the row 1, we are going to copy. Next is the formula in order to get the row 2 again, to make the 2.9 into 1. We have row 2 divided by 2.9, and it results to 0, 1, and negative 3. So, copy the row 1 given from the previous answer. So next, we are going to make the 1/3 into 0. So row 1 minus 1/3, row 2, it results to 0. So 1, 0, and 4. Copy the row 2, 0, 1, negative 3. As you can see, the values of our x and y is 4 and negative 3. So it is the same answer from the Cramer's method. So let us check if the inverse method has its same answer. So we have here the inverse method. We are going to separate its a, the x, and the b. A is equal to 6.3, 1.5, 2.1, and 3.4 for the x, and y. B is 18.9, negative 4.2. So, our determinant A is 18.27. In order to get the inverse of the A, so we have here A to the negative 1, 1 over 18.27. So, 3.4, negative 1.5, negative 2.1, and 6.3. So, we are going to put the B value in order to get the inverse of the a, and in order also to get our x and y. So we are going to multiply a and b, and after that we are going to multiply from the given determinant. So as you can see, there is the given already from the multiplied A and B. So it results to 73.08 and negative 54.81. So we are going to multiply and divide. So it results to x is equal to 4 and negative 3. So our x value is 4, y is negative 3. So let's proceed with another equation. Number 36. So, we have here the given equation 2.4x minus 5.2y is equal to negative 8.0. 1.6x plus 2.4y is equal to 64. So, we are going to answer first the Cramer's method, after the Gauss, and lastly the inverse. So, we are going to separate the a and b from what I did in the first equation. So, copy, extract the constant, and also for the b. And cross multiply. So, our determinant a is equal to 14.08. Next, we are going to get our determinant x. So, our determinant x, we are going to replace the column 1 from the b and copy the a on the column 2 in getting the determinant x. So cross multiply. Our determinant x is equal to 14.08. So for the determinant y, we are going to replace the column 2 with a given b. So after that, we are going to cross multiply, and it results to 28.16. So that's what I did. We are going to divide determinant x from the determinant and dy over d. So 14.08 for the x, determinant x, and for the determinant 14.08, so it results to 1. From the determinant y is equal to 28.16 over the determinant 14.08, so it results to 2. So our x is equal to 1, y is 2. So let us proceed with the Gauss-Jordan method. So we have to extract another constant and make it in augmented matrix. As you can see, there is a augmented matrix already: 1.6, 2.4, 2.4, negative 5.2, 6.4, and negative 8.0. In order to make the row 1, column 1 into 1, we are going to apply the formula row 1 over 1 minus 6. So it results to 1, 1.5, and 4. So copy the row 2 given. So next, we are going to make the row 2, column 1, 0. So the formula is row 2 minus 2.4 R1. So it results to 0, negative 8.8, and negative 17.6. So copy the row 1. So next, we are going to make our row 1 the, no, by the way, for the row 2, yes, to make the negative 8.81, so we're going to divide row 2 divided by negative 8.8, so it results to 1. So copy the row 1. Next, we are going to apply the formula. So the answer will be 1, 0, 1.5, 1, 4, and 2. So we are now going to make the 1.5 into 0 to make a diagonal 1 and 1. So row 1 minus 1.5, row 2 is equal to 0. So we have here the value of our x and y. X is equal to 1, y is equal to 2. So we are going to move to the inverse method. So as we are going to get the inverse from the first column, first row, we are going to swap it with its opposite side. For the row 1, column 2, we are going to swap it and make it negative. So you can see. So our determinant A is already negative 14.08 as what the determinant A given. So it results to negative 14.08. So we are going to multiply A and B. So it results to negative 14.08 and negative 28.16. And we are going to multiply and divide with the given determinant. So it results to 1 and 2. So our x is equal to 1, y is equal to 2. So let's proceed with another equation. Okay, number 37. 371x plus 285y is equal to 2,726. 137x plus 125y is equal to 977. So, let us compute first for the Cramer's method. So, we have to extract a and b for the coefficient matrix and constant matrix. So we have here 371, 137, 285, and 125 for the B, 2,726, and 977. So let us get the determinant A. So we're going to focus with the A and cross multiply. So the results for the determinant A is equal to 7,330. Next, we are going to get the determinant x. So we're going to replace, as what I've said, the row 1 from the B in order to get the x. So our determinant x is already 62,305. So for our determinant y, we are going to replace the column 2 to our B. So it results for our determinant y is equal to negative 10,995. So in order to get the x and y, since it is a 2 by 2, okay? So dx over d is equal to 62,305 divided by the determinant 7,330. So for our y, dy over d is equal to negative 10,995 divided by 7,330. So, for our x is equal to 8.5, y is equal to negative 1.5. So, now our x and y is equal to 8.5 and negative 1.5. Gauss-Jordan in order to get another answer if they are equal. So, we are going to apply the augmented matrix. So, the formula given in order to make the row 2 column 1, 1 is row 1 divided by 371. So, it results to, so you can see 1, 137, 0.76819, 25. Okay, so another formula in order to make the row 2, column 2, 1, we have here row 2 minus 137 times row 1. So it results already to 1. And copy for the row 1. Next, we are going to proceed. We are going to make the row 1, column 2, it lessen the number of the B. So, we have here 0, 1, negative 105. So, copy the row 1. So, we have now the smaller amount of numbers. So, row 1 minus the row column 2, row 1 times row 2. So, it results to 1001. So, it is diagonal into 1. So, the remaining number would be 8.5 and negative 1.5. So, we have now the answer. X is equal to 8.5, y is equal to negative 1.5. So, let us proceed with the inverse method. So, our determinant A is equal to 7,330 and apply the inverse. And from the inverse, we are going to multiply the inverse A and the B. So, it results to 62,305 and negative 10,995. So, divide and multiply and divide with the 1 over 7,330. So, it results to 8.5 and negative 1.5. So, our x and y for the inverse method is 8.5 and negative 1.5. So, let us proceed with the number 38. 325x minus 175y is equal to negative 625. 173x minus 276y is equal to 33. Apply the Cramer's method. So, get the coefficient matrix for A, constant matrix for B, cross multiply, and our determinant A is equal to negative 59,425. So, we're going to get its determinant X. So, replace B for the column 1, so cross multiply. So, our determinant X is equal to 178,275. So, for our determinant Y, we are going to replace the column 2 for the B given. So, cross multiply. So, we have now the answer 118,850. So, next, we are going to divide dx divided by d and dy divided by d in order to get the x and the y, since it is another 2 by 2. Okay, so from the answer of determinant x divided by our determinant, so it results to negative 3. Answer from our determinant y and divided by our determinant is equal to negative 2. So now, our answer is x is equal to negative 3 and y is equal to negative 2. So let us proceed with the Gauss-Jordan method. Augmented matrix. So, after that, we are going to make the row 1, column 1 into 1. So, row 1 divided by 325 is equal to 1. So, copy the column, to row 2 and also the column 1, row 2. Okay, so let us proceed. We are going to make the row 2, column 1 into 0. So, we have here the formula. Row 2 minus 173 times row 1. So, it makes 0. So, our next formula would be, we are going to make the row 2, column 2 into 1 to make it diagonal 1. So, row 2 divided by negative 184.8848. So, it results already on 1 in diagonal. So, next, we are going to make the row 2, column 2, row 1, 0 in order to get the x and y. So, row 1 minus negative 0.53846 times row 2 is equal to 0. So, the remaining number in the right side would be negative 3 and negative 2. So, that numbers are the value of our x and y. So x is equal to negative 3 and y is equal to negative 2. So now, let us proceed with the inverse method. So our inverse method. So, as the determinant given in the Cramer's rule, we have 59,425. So, we are going to inverse the A and multiply with the B given. After we are going to multiply, we are going to multiply again with our determinant. So, from that step-by-step formula, we have now reached in getting the x and y. So, x is equal to negative 3 and y is equal to negative 2. So, x is equal to negative 3 and y is equal to negative 2. So, let us proceed with another equation. Number 39. So, in this 39 and 40. So, the equation 39 and 40 is a 3 by 3 already. So, we have here the given x plus y minus 2z is equal to 0. 3x minus 2y minus z is equal to 0. And negative x plus 4y minus 3z is equal to 0. First, let us apply the Cramer's rule. So, for the coefficient matrix A and the constant matrix B. And get its determinant A, so it results to 0. So 0, the determinant 0 cannot be used to find unique solutions. So it indicates infinitely many solutions. So after we get the determinant A is equal to 0, so we are going to proceed with the Gauss-Jordan. After that, so we have here the different formulas. And for the right side, it's always 0. And we are expecting that for the right side, it is infinitely many solutions since we already reached at the bottom point, which is 0 0 0, and for the right side 0 0 0. So it shows infinitely many solutions. So we cannot proceed in the inverse method since, as we calculated in the Cramer's rule, the determinant is 0 and therefore the inverse is not exist. So not invertible. So let us proceed with the number 40, last number. So x plus 2y minus 2 is equal to 5. 2x plus y plus 2z is equal to negative is equal to 3. X minus y plus 3z is equal to 0. So Cramer's rule again. For the coefficient matrix A and the constant matrix B, get the determinant A, so it results again 0, do not exist. So the Cramer's rule cannot be applied to find out a unique solution. So we are going to proceed with the Gauss-Jordan method. So as you can see in the last part, we already reached at the last row, 0 0 0. 0x plus 0y plus 0z is equal to negative 2 corresponds that equation. So it is a contradiction and has no solutions. So we cannot expect that the inverse method exists. So from the Cramer's method, as we compute, it results again with the determinant 0. And so we expect again that inverse cannot be solved and the coefficient matrix is not invertible. And that concludes my discussion about the three system of equations: Cramer's rule, the Gauss-Jordan, and the inverse method. Thank you for listening. I hope you understand what I am discussing step by step from the three system equation. Thank you.